Hi guys, Elliot here from the product team at Soundcraft, and welcome to chapter 4 of our UI series tutorial videos. Today I'm going to be taking you through the edit page. Moving along our L2 navigation bar, we reached the Dynamics page. In here we have much the same kind of display as you saw in the EQ page, but now we can see controls for a compressor and a built-in noise gate as well. To the left here we have a compressor graph that has two grabbable points, a threshold control here, and a ratio as well. A compressor works by reducing the dynamic range of an incoming signal and leveling the output to a more consistent volume. By setting a threshold, we can set the point at which audio that breaches this point will be compressed, but audio below this point will be left alone. You can see there on this graph that the threshold is now set at -20. So when an incoming signal comes through the threshold and reaches -10, it will then be compressed by our compressor. Now the level of compression at which that signal will be affected by is set by this ratio control here. You can see to the right we have a few numbers popping up here as I adjust the ratio. Ratio moves from 1 all the way down to infinity. If I set the ratio to a setting of 2 to 1, a peak that is 2 dBs over the threshold will be reduced to only 1 dB. So if a signal is 10 dB over the threshold, the outcoming signal will be reduced by 5 dB. If there's a peak of 20 dB, it will be reduced to 10, and so on. If I want a more severe compression, I can move this down to around 3 maybe, or further on for more limiting effects, like infinity. So basically, any signal that breaches the threshold will be reduced drastically so that no signal breaches the volume set by the threshold. By using this graph, you get a good visual representation of how your ratio is going to affect your signal coming in. If I set the ratio to 1, you can see that audio that comes into the console at -20 will then come out the compressor at -20. If audio comes in to the console at -10, the compressor will not affect the signal, and the signal will pass through again at -10 dB. If I bring this threshold back to the limiting threshold here, we can see that if a signal comes in at -20, it is going to come out at -20. And if the signal comes in at -10, it's definitely going to come back out at -20 dB. A real-time visualization of this effect can be seen with these 3 meters here. This first meter is our input meter. This is for the signal that is coming into the compressor from the EQ. You can see these 2 little blue points here. That is where the threshold lives in relation to the input signal. If I move the threshold up, you can see those points move. If I had an input signal that had a bit more dynamic range and was moving a bit more obviously, I could bring the threshold down to the point where a reasonable amount of signal is going over the threshold, but it's not constantly over the threshold like it is now. The second meter you see here is the output meter. The output meter measures the signal that is leaving the compressor. So you can see here, if I look at these 2 meters together, the input and output, you can see the output is quieter than the input signal. Now this is normal on a compressor, but we can make up for that gain loss here by using the gain control. Now we could just increase the gain control here until our input and output signals are pretty close like that. So now I'm confident that the signal entering my compressor is the same volume that is leaving my compressor. Or I could look at this third meter here. Now this is our gain reduction meter. This shows us how many dBs of gain reduction is occurring on that input signal. We can see that to being around maybe -10 dBs of compression. You can see that here if I follow that across. -10. So that means I can boost the gain by around 10. I've ended up at 8.5 here, but we know we're in the ballpark here. We're not losing loads of signal whilst going through the compressor. Moving across from the graph, we can see we have controls for the ratio, which is the same as the grab point on the graph itself, the attack of the compressor, so how long it takes for the compressor to begin compressing the signal, the release control, which is how long the compressor takes to release the signal that has just gone over the threshold, and then the makeup gain over here, which is what we used to bring up our output signal level with our input signal. You can see here as well, as if the gain is set a little bit too hot, I have a clipping output meter here. I've got to back that down a little bit to avoid any distortion sounds or clipping sounds. Below these fine adjust settings, you can see that I have 3 buttons here. I have a bypass button here, which bypasses the compressor and gate. A reset button, which obviously resets the compressor and the gate to factory default. And then we have a hard and soft knee control here. That's what we call a hard knee. A soft knee will result in a much softer compression sound that isn't quite as obvious to the listener. As well as the compressor, we also have a noise gate here. The noise gate on the UI series is a very simple noise gate. It's easy to set up and it only has one control here, which is a threshold. You can see if I raise this gate threshold, there are a few visual cues that are occurring. A gate control is used to remove unnecessary noise in a signal. So you have a snare drum coming into the mixer. Between each snare drum hit, there will be residual noise that is coming from other parts of the drum kit. They are in such close proximity, it's impossible not to get this. All we want to hear from that snare drum mic is the snare hit itself. The noise in between the snare hits to us isn't important, and we don't want to amplify that into our PA. If we set the gate threshold to the point where anything above the threshold will be snare hit, and anything below the threshold will be the residual noise, the gate will essentially close when the signal drops below the threshold setting. So if I reduce my tone generator here to something more reasonable, I'm just going to reset my compressor as well. You can see around here we have some peaks and then we have some sound that is always there. If I want to just hear those peaks and then remove the residual noise between the peaks, I can bring the gate up to that point. So see, everything below the threshold is always on, essentially, and everything above the threshold is the sound that I want to isolate. So if this was a snare drum, and the snare drum was hitting like this when it was being played, all the residual noise between each hit will be removed. In reality, there is a lot more behind the gate control that you see here. But on the UI console, we give you a gate control that's simple to use, but just as effective. The observant ones among you would have noticed this section at the top of both our EQ and Dynamics page. This presets button is essentially a library of factory saved settings and user saved settings for both our compressor and gate and our EQ here. So if I select the presets button, I'm presented with a list of factory presets. These are EQ settings that we have worked out here at Soundcraft, and we've just given them to you as a quick guide point. To say this was a acoustic guitar, I could just load up acoustic now. Let me just turn that on. And now you can see we've got a gentle EQ here. You can also see that we have acoustic one loaded up here on the top left. Let's say I have electric guitar coming into the signal. That's just a rough starting point. You could then move on from there and do what you like, essentially. Say you come up with a setting that you quite like the sound of. Let's say this was a reasonable sound for electric guitar. We can save that setting in our presets menu here so that we can recall it later on or recall it on a different channel. We can do that by hitting presets here, going on to the user settings here, then pressing save. So say that was our electric guitar sound. We can type in our name, press OK, and now it is saved. You can see that GTR setting up here. And then say next time we come to use the mixer. We want to load that setting up. Hit presets, select user, double click guitar, or just press load, and then our settings come back. We have presets for all of our processing options within the console, and I will point them out as we move on further. Now, jumping onto our final two tabs on the L2 bar for channel 4, we reach the effects sends here. Now, we like to call this channel-centric sends. What this means is essentially we are sending channel 4 to our effects processor. We have 3 effects processors on the UI12, and you can see them here. So if I erase this reverb fader here, I am now sending our channel 4 into our reverb bus here. We also have a thing called bus-centric contributions, but I'll talk to you about that in a different tutorial. So to the left of this page, we have our 3 sends for reverb, delay and chorus. They're represented on standard channel faders here. You have a mute button and a dB value up here. But also you can see to the right we have some effects parameters here, and they actually follow my selection. So if I select the chorus here, I have the settings for the chorus. If I go back to the reverb, I have the settings for the reverb here as well. Now here are our global reverb parameters. My colleague Sean will be talking more about these in a different tutorial. This page is especially handy for building up a channel from the ground up. So we've adjusted the EQ, the compressor settings, and now we just want to turn this channel up into our reverb, maybe a little bit of delay and no chorus. We can fill that all up from the channel edit page. Finally, we have the aux sends tab up here. Much the same as the effects sends, this is our channel centric bus send page. So from here on channel 4, I can say I want to turn up channel 4 into aux 1 like so, and into aux 2 like this. These faders have the same appointments as you saw in our effects sends page, with a dB value, a mute button, and a fader level here. Down here we can decide whether we want to send channel 4 to aux 1 pre-fader or post-fader. I'll go more into what these are about in my aux sends video coming in a different chapter. You'll also notice these 2 grayed out faders here. Now all will be revealed in my next chapter.